Hello and welcome back. I'm George Crump, Chief Steward of Storage Switzerland. This is part two in making sense of automated tiering. If you're joining this part and haven't seen part one, uh, there should be a link on our website to get you to that. Again, this presentation is being sponsored by F5. So far on the agenda, we've covered a little background on Storage Switzerland, and we've attempted to define, or at least put a definition out there for automated tiering. Next, we want to talk a little bit about how and where to automate tiering. Where does it make the most sense to do that? So typically so far, automated tiering has been implemented in two areas. Block, mostly being delivered by storage system manufacturers at the storage controller level. So this is the controller having some intelligence that it can make decisions on segments of data and moving that data between the different mechanical tiers of storage. There is some differentiation so far in granularity, as well as, I don't know if this is a real word, but agnosticness, as far as can I mix different vendors' products and things like that. In most cases, you have to get the entire set of tiers from a single vendor. And then finally, what we call a QoS functionality. Just because a file is active doesn't mean you necessarily want it to move to solid state disk. You may want to have some policies that you can set that say, okay, don't move this, do move this. And the same thing goes with archive, especially as we start to talk about archiving to either a MAID-based deduplicated device or even cloud storage. We want to be specifically concerned about moving certain types of data to certain types of platforms. And so having some intelligence to allow you to fine-tune that is very important. Where we probably have seen the most work, though, is in the file-based tiering. More popular, it's a more popular application so far in automated tiering. And there's a lot of different solutions out there. However, there's what we describe as a differentiation in placement methods. So there's sort of the cache-based placement where data is used, or the tiering is used to move data in a very, very temporary measure to a higher speed device. And then there's a sustained placement, which is really allows you to both migrate up to faster storage as well as down to more economical or power efficient storage. So let's look at these cache automated tiering systems for a second. First, there's what I call the pure cache automated tiering systems. They are typically inline. They require no or limited changes to the environment, meaning you don't have to repoint all your mount points and things like that. The granularity with these things is typically at a block level, but sometimes maybe at a file level. Typically, thus far, the storage of choice inside the cache ATS is RAM, not SSD, not SAS drives or fiber drives or anything in between. You're essentially accelerating and moving up to RAM. You're talking about a very high write environment because you're reloading that cache often. So RAM is better suited for that than even flash-based SSD. It's ideal for specific or smaller temporal data sets. NAS-hosted databases are probably one of the better examples. Or even temporarily hot files that are being accessed by thousands, if not hundreds of thousands of users. So when the latest Hollywood star gets in trouble for doing something silly, their picture gets posted up and it gets pinged millions of times. That's an example of when that might make sense. It is not typically, at least at this point, what we would describe as a migrate down technology. It is only a performance enhancer. And it's really designed to accelerate a existing NAS. Think of it as a way to get a little bit more mileage out of your existing NAS without having to replace the whole thing. It's really not a consolidation tool. It doesn't take a bunch of NASs and make them look or at least be managed as one instance. Then on the other side is what we call the persistent cache ATS. So this is less temporal, but still temporal to a degree. It's again inline. Does typically require changes to the environment, not a major rehaul, but clearly some mount point changes and things like that. Granularity again is typically at the block level, so subcomponents of files move up and down. And the issue with the block level migration is it can be concern over where exactly is my file. So that's something to pay attention to. The typical storage inside the box itself tends to be a combination of RAM, solid state disk, and high-speed hard disk or mechanical drives. Again, ideal for general, slightly larger, but still temporal data sets. Again, NAS-hosted databases are an example again. VMware images are an example. And what this does, though, is it takes your current NAS and relegates it, if you will, to the archive. And that's fine as long as you can, if your existing NAS has been paid for and it has some archive functionality into it, and you have a lot of excess capacity on it. So things to weigh into the consideration there. It prolongs the life of the existing NAS. There's basically what this is a performance accelerator, so it gives you more performance out of existing NAS. It is and probably more so than the pure cache, where the pure cache really purely accelerates. You're still going to be counting on your NAS and upgrading it and things like this. In the persistent cache, your NAS really becomes a secondary tier storage, and it might be a good fit. It is not a migrate down technology. In other words, this is not the sort of thing where you'll go out and buy a MAID or a deduplicated archive or something of that nature and store data on that. Most importantly, neither will leverage an existing SSD investment. Each one of these that we've seen thus far require you to use the SSD that they select and embed. And so you really don't get the freedom to select your own solid state disk investment, which could be especially concerned if you already have one. Next up is what we call file virtualization systems. This is a form of automated tiering, and we think, especially in the NAS space, probably makes a lot of sense. You can migrate up and down storage tiers, so those tiers can be SATA, fiber, solid state disk. It could be cloud storage. The SATA tier could be deduplicated storage. It could be specific archive tiered storage. It could be MAID storage. It could be a combination of all three. So it really allows you to leverage some of the more interesting cost-saving storage technologies that are out there. It provides the broadest application. It can handle many files, multiple NAS heads, and multiple storage types. So that gives you great flexibility. The storage can already be in place as well. It's important to note that this is not a global file system. And a global file system, although good and certainly has its merits, is really designed to be exclusive to one vendor or operating system. And so you're locked in. It doesn't really consolidate NAS across those.